Hi guys, in earlier video I forgot to mention that we can use these formula also for weak bases. Alright, same as the formula, only thing is it would be Kb instead of Ka. Fine. Okay, now let's proceed with autoionization of water. Now, water we all know is a weak acid. Alright, water reacts with its own self. Alright, so one has to act as an acid, other has to act as a base. Alright, so that's what happens. That's what we see over here. We find that proton given over here. If I assume this to be an acid, this has provided proton to this water and formed it as H3O plus, whereas it has lost its proton, so it became OH minus. Alright, so this is how it does autoionization. Alright, okay, so again I repeat this. Assuming this acts as an acid, so it has given its H plus to this and formed H3O hydronium ion, and since it has lost its H plus, so it forms OH minus. So we formed acid and base in aqueous medium in water. Alright, and this is what is autoionization of water. Fine. Now equilibrium constant we all know. This formula we are quite familiar with. Now another thing that we know is that water dissociation of water is very poor. Alright, it's weak acid or base, whatever you call it as. Alright, so what happens is we have maximum quantity of water over here, undissociated, maximum quantity of unautoionized water stays. Alright, so now what I do is I take this the other side. Alright, now H2O square, this becomes equal to H3O plus concentration of OH minus. Now this concentration of water over here is pretty high, much higher in comparison to this, so we put it as constant. Assume that unautoionized water, that is this water is say 99.8%, and there is just 0.2% of autoionized water. Alright, so what difference does it make to this? 99.8, 0.2 is nothing in front of 99.8%. So we assume that it is always 99.8% only, and keeping that in mind, we assign it yet another constant, which we call it as K prime, is equal to, now same thing I write it as H3O plus concentration, OH minus concentration. These two constants, when we multiply, it becomes yet another constant, and that constant we call it as ionic product of water. Why? Because this is the ionic product, so this constant is the ionic product of water. Alright, now another interesting thing, at 298 Kelvin, or it's 27 degrees, right? 27 degrees Celsius. At that temperature, what we find is the concentration of this is 1 into 10 raised to minus 7 moles per liter, and that of this also is 1 into 10 raised to minus 7 10 raised to minus 7 moles per liter. So when you multiply this becomes 10 raised to minus 14. Alright, so that is what is kW at 298 K. For simplicity's sake, what I am doing is I am just putting the values. Alright, so it is 10 raised to minus 7 into 10 raised to minus 7, and what is that? That is ionic product of water, H3O plus and OH minus, ionic product of water. So this gets the value of 10 raised to minus 14. So now I want to introduce log. Now we know the rule for log. What is it? When we put log, this comes down and this goes here. Alright, so I put here log here first. Log of H3O plus OH minus. Alright, Now I have introduced log, so I had already taught you that this comes down and this goes as base of 10, and this takes this place of 10, so it is minus 14. This is in maths that we have learned a lot. Alright, so this becomes this. Now if I take log inside the bracket, that also we know this is multiplication, so this becomes log to the base 10. Can I write here H plus ion? I would write here H plus concentration of hydrogen ion, because this is hydrogen ion, right? Plus multiplication turns plus log OH concentration of hydroxide to the base 10 is equal to minus 14. Alright. Now if I take minus this side, so it would be minus log of hydrogen ion concentration to the base 10 minus, this also is multiplied by minus, so minus log of hydroxide to the base 10 is equal to 40. Now this is what we call as pH, this is what we call as pOH, so minus. Alright, so it would be now what I would do is I will put it here itself, it is minus. Alright, so minus log of hydroxide to the base 10 minus log, if you want I can also put bracket here, so both are added, right? So this is what it is, what you get. Now this is what is called as pH, hydrogen ion concentration, plus pOH is equal to 40. This is how we get the range of pH and pOH. Alright.